Hello, Math Stars. We are on our third lesson, which is expressions. Okay, so before we move on, so the expression page is page 5 and 6. And again, it's one of those work out the problems. You see if your answer matches one of the answers on the fish and you color it in. So that's a fun way to be self-checking. But before we jump into the page in the booklet, I want to do a little review with you. So first thing is to understand the difference between an equation and an expression. Okay? An equation is a number sentence with a relationship symbol. Relationship symbols are like greater than, less than, or equal to. They tell two sides of something. So if I have 2 plus 3 equals 5, my relationship symbol is the equal sign. I am explaining what is the relationship between the 5 and the 2 plus the 3. It's that they are equal. Okay? An expression, and that's what we're working on today, is a combination of numbers and at least one operation. Okay? It's a combination. You are not solving. You are not solving anything. You're just kind of rewriting numbers into a word statement, or you're taking a word statement and putting it into numbers. But we are not finding the connection between two sides, so we are not solving for anything. Okay, so an example is when writing equations, match the words to their number forms. Watch for keywords that tell you what operation to use. For addition, subtraction, multiplication, and division. This math language is very important for expressions. You need to know that sum means addition, difference means subtraction, product means multiplication, and quotient means division. You have to know those. Okay? So for example, I'm going to take this statement, I'm going to match it to numbers and create an expression. I have 9 cookies and want 4 more. Right? So you have 9 of something and you want 4 more. So if you want something, you want to increase. So you're going to add 9 plus 4. That's your expression. Notice this does not ask how many cookies will I have in all. If it asked how many cookies do you want in all, that would be an equation. We're only working with expressions. She had 15 pencils, but lost 7 in the hallway. She had 15, and then she lost. What operation do you connect to when you lose something? Subtraction. That's an expression. They did not ask you how many pencils does she now have. Number 3, the librarian had 5 copies of 6 different books. Well, if you have copies of something, what operation is copies? Copies mean to duplicate something over and over. When you duplicate something over and over, you're multiplying. So she had 5 copies of 6 books. Again, they're not asking how many books does she have in all. That would be an equation. We're writing expressions. Okay. Miss Amanda made 4 salads for each of the 9 classrooms. So if she has 4 salads, and each, we're gonna increase by some amount of the 9 classrooms. So she has 4 salads, each for the 9 classrooms. Okay? Those are all expressions because we are just making a statement based on the sentence we are given. We were not asked to solve. So we will have a practice page. So I would suggest, I'm going to blow this up a little bit. Okay. So I recommend you pausing the video, and you have a piece of paper and you number your paper 1 through 8, and you try to match the expressions. And then when you give it a try, you can press play again and see if you are correct. Okay? So now it says write the expression to match the words. Again, we are not solving. We are just write the expression, not solving. If the question wanted us to solve something, they would have given us some sort of a relationship symbol, greater than, less than, or equal to. Okay. So let's focus on the math language. The difference of 10 and 3. Okay. We have a difference. What operation is difference? So circle, whenever we're working with expressions or taking notes, circle the key words and make a think track about what that word means. Difference means to subtract. The difference of 10 and 3. Whenever you see the word and, that means the two numbers that are around it, the one that becomes before it and the one that comes after it, they go together. So we want to know the difference of 10 and 3. Simple enough. The product. What keyword is product? Multiplication. The product of 5 and 9. These two numbers are going to go together. Try to keep things in the same order. 10 comes first, you put 10 here. Then the 3, then the 3. 5 and 5, 9 and 9. The sum, what does sum mean? What operation? Addition. The sum of 3 and 11. These two go together. Okay. The quotient of 20 and 2. What operation is quotient? Division. Of 20 and 2. These two numbers go together because they're separated by an and. Now here we throw in an extra step. These were pretty simple with just dealing with two numbers. Now we're going to get more into orders of operation and have a third step thrown in there. 1/2, we know that's going to be important. The sum of, we know what sum means, 9 and 3. And we know that 9 and 3 are going to go together because they're around the and. So when you want 1/2, typically would think of this, right? But in expressions, we don't see too much of the half fraction. But what number represents half of something? Whenever you want to split something in half, we automatically get 2. So choose the 2 over the 1/2 fraction when writing expressions. So we want half of, so whatever our other numbers are going to be, we know we're going to want half of that. Okay? We want half of the sum of 9 and 3. You might wonder, why did I put the parentheses around the 9 and 3? Well, as we noticed up on top, the numbers belong to each other when they're separated by and. Okay, so you have to make sure that they go together when there's other steps involved. If I didn't have parentheses, according to our rules of operation, the 3 and the 3 divided by 2 would have to go together because division is more important than addition. But we have to make sure that these two stick together, so we have to put the parentheses around that. That is why the sum of 9 and 3 have to go together. We have to protect it. We have to keep them together by using parentheses. Then 1/2 of that sum. So we come up with the sum, and then we're going to get 1/2 of it. Okay. So down to 6. 2 times the difference of 5 and 3. Okay, keep in mind difference. We know that these two numbers are going to go together and they connect to the difference. And then whatever this is, we want 2 times. So we're going to put 2 times the difference of 5 and 3. 2 times the difference of 5, take away 3. Okay. The quotient means division, of 15 and 3 minus 4. Super got tricky here, because now there's more math language involved. The quotient of 15 and 3, so we know that those two together because they're around the and symbol, minus 4. So we want this quotient of 15 and 3, and then at the end we want a minus 4. The parentheses aren't as necessary here because if the parentheses were taken away, we'd still have to connect 15 and 3 together because division is more important than subtraction, but it's good just to keep in good practice. Okay, and the last one, 7 times 4, then add 10. So let's circle what we know. We know times. We know 7 times 4, then add 10. We know add means that, and 10. Okay, here's a new word we're throwing in there. Then means after. Then means something's going to come after a step before it. And this step is going to be 7 times 4. Then we're going to add 10. Okay? So I have 1/2 of this left. Okay, take a look at these. Give you a moment to give those a try. Pause the video if you need to. Because then after this page, we're going to let you do the packet page. Again, know that the math vocabulary, the math language we're using is very important. Always circle the words that you want to connect to, especially if you get confused at first. This isn't easy. It's kind of like a little puzzle that you have to take apart or decipher. So whenever you feel like you get a little bit lost, connect to what you do know. For example, you definitely know that difference means subtraction. You definitely know divided means the division symbol. You've learned and you've practiced that the two numbers that are around the and symbol have to stick together. The difference of 16 and 2. Okay, well, those have to stick together, and there's another step. So I'm going to use parentheses. 16 take away 2. And divided by 7. That's our second step. Divided by 7. Okay, 10. The product of 8 and 5 divided by 4. So we want the product of 8 and 5. The parentheses aren't as necessary, but I do want to just keep in good practice. When you know two parts have to go together, just throw parentheses. You're not going to get marked off points for having an extra set of parentheses if it doesn't change the overall answer. So the product of 8 and 5 divided by 4. Okay. Now, here's the opposite. You get to write the words to go with the phrase. So let's review what we've learned. When two numbers are in a parenthesis, they have to go together. So you're going to have to use the word and to show that these two go together. And then whatever the operation is, you use that wording that comes right before it. So if we take what we know, we're going to say the sum of, what are our two numbers? 3 and 5. What word connects to multiplication? Times 7. There you go. So all it took was breaking up, stemming off of the numbers, and celebrating what you do know. Multiplication means times. When you have parentheses, you know that those two numbers go together, and you represent they go together by using the word and. The operation word goes